Okay. I think in the previous lab actually we discussed about the basic flow design for both analog as well as digital design, right? Digital design flow as well as analog design flow, right? So today I will start the lab and we'll work with the Cadence tool basically. First we'll start with the digital design. Okay. We'll do some up to simulation. Then in the next lab we'll do for synthesis and all these things. Okay. Fine. Just for remembering, so what we have as steps in a front end design. So we actually have the specifications. Usually we get from the clients. Then we go for architectural design, overview of the complete design. Then we go for RTL design. That means RTL code, Verila code we're going to write. So for that again we go for verification by writing this test bench. So wait for we have to check for its simulation results. Then after that we go for synthesis by basically in the RTL design we write Verila code, right, using module. So all these things, in order to check whether to verify my RTL code is working properly or not, we're going to write its test bench for simulation purpose. So once we write that, then we go for synthesis. Basically, synthesis is done using TCL language, where we're going to write a TCL code for that. So using that command, so actually we execute synthesis, and that means it's add where description. We do that, right? For synthesis, we're going to write TCL code, tool command language. It's basically that that we'll also discuss fine in future. Fine. So we'll do till here. Fine. So these steps we called as the front end steps, right? In the front end design, we actually do all these things. So in the back end, we go for all these things: design for testability, then for plan, then placements, right? For all these things we done in the back end. So again, in future, we're going to learn all these things also, right? So today we'll deal with till RTL verification, right? By writing a test bench code, we'll write till here, right? Okay. Then we start with, so what are the steps we are supposed to follow for digital design? Because henceforth you're going to have your separate system for you people. So you have to store all. You have to save all your work into that into that system only. For that reason, so what you're supposed to do? There's a roadmap, right? Usually the default path for Cadence will be this home Cadence, right? So what you have to do is inside this, so inside this folder, create your own folder with your USN. Fine. So once you create that folder, so in future, any work you do, any kind of experiments you do, everything should be saved in that folder only. Fine. So first we have to create uh, a folder or directory basically. So that will be in your USN name. Fine. So under that, we're going to create 4 more subfolders. So one is RTL. ಬರ್ತಲ್ವಾ ಕಟ್ ಆಗ್ತಿದೆಯಾ ಈಗ ಬರ್ತಿದೆ ನೋಡು so first what you have to do is again to go to this path is the default path for Cadence tool. So inside that you have to create your own directory with your USN. So anything is just a name, so 19 is in 999. So with your USN you create better, right? So that henceforth if you want to access your data, so you can access easily. So you can go to that folder, you can access it, right? So throughout this semester you'll have your separate your own system for accessing Cadence. So inside that you have to create this. And for digital purpose, digital design purpose, so what we do, so under this means under your directory, so we're going to create 4 more subdirectories, subfolders, so with the name RTL, TCL, library and work, right? For as I said, we're going to discuss up to synthesis now. So in order to save, in order to store the data in a separate manner, so we're going to create these folders, right? Other than that, there is no advantage of this. Fine. So in RTL folder, we're going to store all the RTL codes, basically Verilog files. So whatever we're going to write, the Verilog files ends with .v files, right? RTL codes that will be stored in RTL folder, right? That means so you have to go to into this folder, then you have to write a code. Then all the TCL scripting files, right? This is for synthesis purpose. So all those files, TCL scripting files will be stored in TCL folder. Fine, this is for the synthesis. Then the corresponding, for synthesis purpose, the corresponding tools library files, and we're going to use different library files. I'll tell you when once we go with the synthesis, I'll tell you there what all the libraries we're going to use, make use of that. So basically it's a GPT-45 will be used. So those the library files that are essential for synthesis, that will be stored in library file and library folder, and all the reports that you're going to generate, that means power delay and area, all the reports that you're going to generate after synthesis, so that will be stored in work folder. Fine, so that is the advantage of this. Other than that, there is nothing like, so you have to create these folders, but just for the clarity, so when you are accessing the data, it will be useful, right? For that reason, so we have to create 4 more subfolders. Then we go for the Cadence tool. Okay, I hope it is clear till now. So we have to how to go to this path. You create your own directory. Inside that, create 4 more subfolders. Inside this folder, you're going to create a Verilog code files. Then inside TCL, you're going to write TCL scripting files. Then under library, you're going to store all the library files that are necessary. Fine. Under work, so you're going to store all the reports that you're going to generate, power delay and area. Fine. And the components required. Fine. So all those uh, timing analysis, so all these things will be generated, that will be stored here. That's why the name is worker. That's all clear. Okay, we'll start with Cadence. So what you have to do is, so if I go fast, kindly let me know there itself. Okay, fine. So what we do, right click on the screen, go to open in terminal. So open the terminal. So right click, open in terminal. Fine. In open terminal, fine, the first command that you have to use is csh. Fine, click enter. Fine, basically csh is C shell, right? It's actually acts as a bridge between your kernel and your the user interface. So basically in order to interface with your Cadence tool, so that it's an application, right? So that will create the bridge, or it's like bridge between your kernel and your Cadence tool. Fine, or user interface basically. Fine, so that you have to invoke first, right? For that, to invoke C shell, so this is the command csh. Fine. Next is, your Cadence uses a lot of environments and libraries and tools, right, for performing different operations, right? So as we have seen in a design flow, so we do a lot of operations, right? For that, it needs a lot of design environments, then tools, right? So that has to be invoked first, right? That has to be set for your Cadence, right? For that reason, to invoke all the design environments for Cadence tool, we use cs source csh-rc. Fine, this is the command to invoke all the design environments. Usually that will be, what is the csh-rc is, it's basically a file, right? You can see on the screen here, right? It's basically a file. So in this, so we'll have the, so all the commands corresponding to all the design environments, right? Home, Asura, then PVS, MM, right? So RC, then QRC. So all these corresponding in design environments will be written here. So that will execute first, right? So before you invoke Cadence, you have to invoke this first. Fine. For that, so the command is source csh-rc, right? Once you enter, you will see this welcome message, right? Welcome to Cadence training. So that means you have invoked Cadence properly. Fine. Okay. Once you have invoked Cadence, so what I said, so you have to set the default path. This you have to go to this path, right? For Cadence, so the default path set is this home Cadence. So inside that only you have to create your own directory. Fine. So now we are on desktop. Right? If you see here, we are on desktop. Fine. So what we do? So in order to change the directory, so this is cd space slash home slash Cadence. Fine. This is the command to change the directory or to set the default path for Cadence. Fine. Basically, we will be on when we enter the Cadence training. So once we enter the Cadence, so we'll be at desktop. Fine. So to enter the Cadence, or to set the default path, so we have to change the directory. For that, the command is cd. Stands for change directory. Fine. Cd space slash home slash Cadence. Fine. So the space must be there. Fine. Enter. Fine. Now for Cadence, I have set the default path. Now I'm here. Right. I'm here. Fine. So what I have to do? I have to create my directory. Fine, with my USN. So to create my own directory, so the command is make dir, make directory. So mkdir refers to that. Right? This is the command to create directory. Fine. Space. So you have to give the directory name. Right. For that you have to give corresponding USN. Fine. Give your corresponding USN. So that will create the directory, right, with your USN. So inside this Cadence. Fine. To create that, this is the directory. Make directory mkdir. Fine. Once you enter, so it has created 4VV16EC XXX directory. Fine. So you will going to give your own USN number. Fine. Now it has created the directory with this name. Right. You can check that. So if you want to check the path for this, you can check. Fine. Now see, so your directory will be inside this. Fine. So you have created. So under Cadence, you have created 4VV16EC XXX. Now what I have to do? Once I created this, my USN. So inside this folder, I have to create these 4 subfolders. Fine. RTL, TCL, library, and this. So currently I am in what? I am in Cadence. So in the Cadence I have created this, but I have not entered into my directory. Right. For that, again what I have to do? cd space this name 4VV16EC success. Fine. Change directory. Now you can see I am inside my directory. Now I entered into my directory. Now what I have to do? Inside this directory I have to create 4 more subfolders: RTL, TCL, library, and work. Fine. This is just to store the different files into different folders. That's it. Other than that, there is no use of this. Right. That's the best way to practice. Okay. Now inside this folder I have to create 4 more subfolders. So how to create? Again same thing. mkdir make directory. RTL is a folder. RTL. Then you can give using a space. How many folders you want? You can give the names with spaces. So it will take. Fine. Or you can give one by one. Make directory RTL, make directory library, make directory work, and make directory TCL. Like that you can also give. Right. Okay. I will give here only TCL. Then I need library, and to store the work results, so I'll create one more folder, work. Fine. Now I have created 4 more subfolders inside my directory. Right. To check whether I have created and all, so what are all the folders that are there inside this directory, I can check that also. Right. To check, I'll command is ls. Right. If I give, it will show. Right. See, library is there, RTL folder is there, TCL is there, work is there. Fine. So once I created this, next is what? Next is, so again specifications architecture, again that will be given. So once we write that, we have to write the RTL design. Right. For RTL design means we're going to write the RTL code. That means Verilog code we will go to write. Right. So where we are supposed to store that Verilog files? We are supposed to store in RTL folder. Now currently currently I'm in this folder in my directory, but inside that there are 4 subfolders. So but where I have to supposed to store my file into this folder RTL, right? But currently I am in this folder, right? So I have to enter RTL first, then I have to write the corresponding Verilog code inside that, right? For that again same thing. So how to change the directory? CD RTL. Now it will change to RTL. Now see, I am in RTL folder. Inside this I have to write the code. Fine. Okay, so to write the code, first I have to open the writing window, right? Notepad is just like, right? So how to open that is using this gedit window. So gedit is the command to open a writing window. It's just like a notepad in your Windows, right? Here it will is there, so gedit is there, right? So that will open a writing pad. Fine, so that will be useful for us, right? So I'll write gedit with the name, right? So I have to give the name of the file, right? So let me take a simple example of an AND gate or maybe OR gate. Let me take an AND gate. So and and3.v. Fine. So what is this and3.v is? Basically is the file name. Fine, the extension of the file is .v, because I'll going to write the Verilog code. The extension of Verilog code file will be .v, right? For that, so gedit is the writing window command file. It will open the writing window command. Fine, there I'll going to write the file name. So this is my file name. Inside that I'll going to write the code. Fine. Okay, click on that. It will open the writing window. So here you can see. So and3.v is my file name. So here you can observe, so the corresponding uh, path is also showing. So it is in 4VV16EC XSX under RTL. Inside that I am writing this file. Okay, so okay, here I am going to write my functional code. So let me write the Verilog code module. Let me give the module name and 3. So better you give the same name, whatever the file name you give, better you give the same name for module also. So I'll tell you why. So it will reduce the confusions when you're doing the synthesis and when you're elaborating your design, so it will be useful, right? So I'll write the arguments. I need A, B and C, right? Then I need input A comma B, then output C. Sorry, I basically forgot. Let me check. Testing and okay, output now. It is here only. Okay, it's a simple code. Fine. So input AB, output C. So the equation fix and assign as C is equal to A and B. Right? End module. Right. Now save this. I've written the code. Right. Now I've saved this under and3.v. Fine. Once you write the and3.v. Okay, let me minimize this. Okay. So once you write this code, let me close that. So this is the code for my functional diagram. So whatever I've written here, right? So RTL design code I have written, but to verify the code, so I have to write what? I have to write its test bench code also, right? So by writing its input and output, right? Input sequence, right? So for AND gate, you'll have 4 combinations: 0, 0, 1, 0, and 1, 1, and 1, 0, right? So you have to give the its test bench for simulation purpose. At the same time, you can write afterwards, or you can write same at the same time for verification, right? So once we have written Verilog code for this, for the simulation, I have to write it's test bench. For that, let me write and 3 score test.v, another file. Fine, that is for writing the test bench, right? So again, to write that, again I need one more file. So for that, again I'm opening gedit, right? Using gedit, I'll open and 3 underscore test.v. Fine, open. Again, for writing test bench code, let me take test code and test v. Fine, so this is my test bench code. Fine, let me write this. So module name and 3 I'm using, right? So this is the instance I'm using in order to check the input or output by writing all the code. So input I've declared as a register, then wire C. So for initial, all the conditions I've given for 0 0 and 0 1 and 1 0 and 0 0. Fine. Now I will save this and I've written both. Now we can check. So I've written the Verilog code as well as its test bench. Fine. So am I going first? Are you following? So till now what we did, so we invoked C shell, then we invoked all the design environments for Cadence using source cshRC, then we set the path cd/om/cadence, then we created our directory, then we entered into our directory, then inside the directory again we have created 4 more directories: RTL, TCL, library and work. Then we entered into the RTL folder. There we have created 2 files using gedit. One is and3.v. You may ask why and3, why not and? And is basically a command, right? Basically it will consider it as a command, right? So that's why. So we're not going to use that. Right? So that's why I've given and3. You can give any other names also. Right? And3.v is a Verilog code, right, for AND gate. Then to verify its simulation working, we have to write the test bench code for that. For that, I have used and3 underscore test.v, and we have written both, right? Now to verify it, we use a tool called as nc launch. Fine. So nc launch is actually gives GUI for verifying all the codes, right, for synthesis and simulation and synthesis purpose. Fine. So nc launch is the command to invoke GUI for simulation and verification. Sorry, simulation and synthesis. Fine. So remember this nc launch, nc launch. So once you click on that, so a window will appear. Fine, like this. So if it is not visible from your mobile phone, kindly zoom in. Kindly zoom in your mobile phone, and you can see that. Right? Okay. So by default, it will be in your path only. So whatever the folder that you have saved, usually in that folder only it will be there. If not, so what is the first step is, once you enter the NC launch window, right? What is the first step is you have to set the design directory. Fine, we do in both analog and digital design. First you have to set the design directory. So whatever the directory you have created, fine, you have to set the path for same in NC launch. Fine. For that, what we have to do is go to file, in file, find set design directory. Fine. I hope it is visible. In file, select set design directory. Fine. Click on that. File, set design directory. Inside that, so the first option is design directory, right? Usually the default path will be there. If not, you have to select your own folder, right? Your own design directory you have created. Inside that RTL folder you have to create. Fine, you have to select here. You have to set the path basically. By clicking on this, in the right side you can see this 3 dots. So if you click on that, so new window will appear. like this. So by going there, you have to set the path. Now by default, my directory is already there, right? So I'm not going to create, right? I'm not going to set again. Now below that you can see something called as library mapping file, right? So below that there is option called as create cds.lib file, right? Under library mapping file, right? So this option called as create cds.lib file. Fine. So this is click on that. If you click on that, so it will ask for saving the file, right? Click on save. Ask for overwrite. Yes. Click overwrite, and it will ask for include the default libraries. Yes. Both VHDL and mixed mode. Yes. Click OK. Fine. So I'll tell you what is CDS lib. Once we go for synthesis, I'll tell you the advantage of this file. Okay. Fine. So once we set this, what we did, we went to file, design, the set design directory. Inside that, under design directory, we have set the path. Below that there is a called as library mapping file. So we have to map all the files. For that you have to create the cds.lib file. So we clicked on that and we saved it. So once we done this, click OK. Fine. Once we done this, now what we do is we'll select and to.v. So no, I think my path is different. Okay. So my default path is not there. Let me go to 1617 ECX. Okay. Select this. Okay. These are my files. So once you do that, once you save the CDS file, so design directory, once you set that, so you can see the files that you have created will appear here, and3.v and 3 underscore test v. This is the Verilog code and its test bench code. Right? It will appear here. Fine. Now what we do is we'll select and3.v Verilog code. We'll check for its errors. For how to do that, select this. Then here you can see. So there's something called as a vlog. Fine. Go here. So select launch Verilog compiler. Fine. So this will verify for its errors. So Verilog code errors. So click on that. If there are no errors in this NC launch window, it will show. So no errors is done properly. So it will not going to show any errors. If there are errors, it will show here in the red mark. Fine. So you have to go back to from here. You have to go back to that edit file. Then you have to edit here and you have to come back. Fine. Fine. And remember, once you edit the gedit window, fine, unless you close this, your command window will not work. Fine. You have to close that, then only the command window will work. Fine. Okay. So we checked what we did, and3.v, we check for errors. The same way for and3 test also. For the same, let's verify its errors. Okay, no errors. So whatever the code I have written, so no errors for that also. Now what we have to do, once we check for errors, fine, so it will create its hardware codes or structures in the worklib file. In the right side, if you check, there is a folder called as worklib. Fine. Inside that, it will create two files with the name and1 as well as and test. Fine, with two modules. Fine, modules worklibs. So with and1 and 2 and test. So this is for Verilog code and this is for test bench. Fine. Now what you have to do, select and1 and come back here. So beside this, launch Verilog compiler, right? Beside that Verilog compiler, we have something called as elaborator. Fine. So click on that. Fine. So once we check for Verilog compiler, then we go for elaborating. Fine. So elaborating is basically it'll try to read the code. So it's a Verilog code. Then it will try to recognize its corresponding hardware modules, right? So whatever the hardware modules you have written inside the code, it will try to recognize those modules, right? That will be put into synthesis format, and all the netlist errors, and that will be for constraints, design constraints. So they're going to check, and it will elaborate, and it will going to recognize its RWeight structures. Fine. So basically, for here in this case, we have written for AND gate, so it will try to recognize the AND gate and its RWeight structure. Fine. For that, we have to elaborate the design. Fine. So again, elaborating will have lot of um, operations. So that I'll tell you once we go for synthesis. I'll tell you in detail. So what are all the things that we do in elaborate design. Fine. So for AND we did the elaboration. Again for AND test also we have to design the same. We have to do the same. Elaborate. Fine. I think there's error and test. So there's a error in this. Let me check. Okay. I have given AND 3. File name was AND 3 and here module name was different. That's why it's showing the error. Okay. Let me do that again. Okay, no errors now. So once we elaborate this, we under work lib, next step is we go for simulation, right? That is verification. So for that, what we have to do is below this work lib, fine, there is a work lib file. Below this, there is something called as snapshots. Fine, there is a folder called as snapshots. So click on this plus icon. Below this, it will create two work libs. One is for AND3, that is for Verilog RTL code, and one is for test bench code, right? So what we have to do is we have to check for simulation, right? So for that we need test bench code, right? What we do, we'll select this test bench module work lib and underscore test slash module, sorry, ampersand module. This has to be set for simulation. So select this file, then come back here. So beside this elaborator, so we have something called as simulator, right? Click on that. So one click on that, so it will enter into simulation environment. Fine, this will looks like this. So let's close this. Fine, so design environment, so simulation environment looks like this. So here select and test. So my it has recognized, so it's corresponding simulation module and test, so this will appear here. If you click on that, its corresponding objects corresponding to input and output lines will appear here in the right side. Fine. Now what you have to do is select these three. Fine, using control select A, B and C, the inputs and outputs, all the input output lines. Then right click on this. If you right click, right, here there's an option called as send to waveform window. Right? There's an option called as send to waveform window. Click on that. Right? It will enter into simulation window. Fine. Here, so for test bench code, we have written all the conditions: a equal to 0, a equal to 1, and b equal to 0, and b equal to 1. Right? We have written all the combinations. So now what we have to do is we have to set the simulation time here to check the simulation. Right? First we have to set the simulation time for how long it has to do the simulation. Then we go for simulation. So how to do that is here. This small icon, run icon is there. Right? So I hope it is here. If it is not, kindly zoom in and check. Fine. Here. Right? So in front of that there is a small arrow mark. A small arrow mark is there. So you have to click on that. If you click on that, it will ask for simulation time. Fine. So we can give simulation time. Usually it will take in nanoseconds. Here you can see, observe, it will take in nanoseconds time scales. So you can give corresponding to the same. Even our and RTL code also, the delay that we have given, it will be in nanoseconds only, right? So here you can give the simulation time. So we have four combinations. Four combination means 10 plus 10 plus 1. We can have 40 nanoseconds. So more than that, let's give around 50 nanoseconds. Fine. So once you give this, you can run the simulation. Click on that. So the simulation will come. And now we can check. To check the for different combinations, if you click on the marker at this point, it will show. See, for A is equal to 0, B equal to 0, C is 0. For 0 0 AND gate, C will be 0. For other conditions, right, 0 1, C will be 0. And for 1 1, C will be 1. When both are 1, AND gate output will be 1. For any other combinations, the output will be 0. Now we have successfully verified its test bench. It is working properly. Clear? So that means we did till here. Okay, let me tell you. So we did till here, RTL verification, right? So once we do that, then we go for synthesis. For synthesis, we write in Cadence, we write TCL language or scripting file for the purpose of synthesis for hardware verification. Fine. Clear? Okay. Any doubts still here? Any doubts? Any doubts still here? Shall I repeat it? Shall I repeat fastly so that I will have the clarity? Right? Shall I repeat for 5 minutes? Okay. Okay. Let me close this. Let me close this also. So the synthesis we'll do in the next lab. Okay. Let me repeat this once again. What I did. What I did. First, I invoked C shell using CSH. Then I invoked all the design environments for Cadence using source CSHRC. Basically, it executes the commands that related to all the design environments of Cadence. Fine. Source CSHRC. CSHRC will have the file here only. Fine. Okay. Once we do this, we can see this. Welcome to Cadence training. Fine. So below that, so usually the default window will be, so the default path will be desktop. So what we have to do for our Cadence, the default path is set to home Cadence. For that reason, we have to change the design directory. Fine. For that, I've used cd space slash home slash cadence. This will set the directory to cadence file. Fine. Now inside that I have to create my own folder. For that I have used make directory for VB16EC XXX. You can create with your USN. Once you created that, below that, so inside this folder I have to create 4 more subfolders. Right. So for that I have to enter into this folder first. For that what I did, cd space 4VB16EC. This will going to change my directory into this folder. Fine. So no, before that you can check the path also. To check the path, so what is my current path, right? You can use this pwd, so that will show the path. Fine. Path for directory. Fine. Now I have changed my directory. I have entered into my directory that I have created. Inside that I have to create 4 more subfolders: RTL, TCL, library, and work. Right, to store the different files in different folders. So for that I have used again make directory RTL, TCL, library, and work. Right. To check the list of the folders that are available inside my directory, I can use ls. Fine. So that will show my this. Now once I do this, this is done with respect to creating directories. Now I have to write the RTL code for my design. For that, so all my RTL codes will be stored in RTL folder. For that, currently I am in this folder. So what I have to do, I have to enter into my RTL folder. For that I have used again change directory RTL. Now inside that I have now. Once I run this command, I will enter my RTL. Now inside this folder I have to write the code for AND gate. I've written. So to write the code for AND gate, so the edit window will be appear using this command. So to use the command, so this will be that. So gedit is the command to open the writing window. Fine. So once you edit, sorry, use this command, you have to give the file name also at the same time, because you're writing Verilog code. I have given the extension .v, right? So and 3.v, right? So once you write the code, you save it, right? So once you execute this, you will save the file. Again, for the same file, in order to check the simulation, you have to write its test bench, right? For the test bench, again you have to write one more file that I have written using gedit and 3 underscore test.v. Right, once we write this and once we save these files, next we have to go for simulation. Right, for that the code is, sorry, the tool is NC launch. Right, this is the tool for verification and digital design purpose, so that we use NC launch. Right, so to invoke that tool, the command is this. Design environment, the command is this, NC launch. Once we do that, so we get this window, NC launch window. So here only it will show the current directory. Right, now inside this, what is the next step is I have to go to file, I have to set my set design directory. Inside the set design directory, I will set my folder by clicking on this three dots. So I'll go back here. Again I'll go back. Now inside the Cadence, here see home/Cadence, I've created my folder for VV16EC XXX. I'll click on that, right? That means I have to create RTL folder. I have to select RTL, then I have to click OK. Now below that again I have to create cds.lib file, right, under library mapping file, right? I have clicked on that, then save, overwrite, yes, click OK. Once you did that, once you set the design directory, the files that you created and Gorilla code as well as test bench, those will appear here. Otherwise you have set the path indifferently, right? Or you might have saved your file in different places, right? You will have to take care of all this thing. That's why I'm explaining again and again, right? Once you does this, so in future it will be easy, so you don't have to do all these things, right, all these steps. So directly you can come here, you can set the path and change directly to this, then you can keep on writing the codes and you can verify it, right? That's why. Okay, so once you've done this, then you have to select both test for errors, this one, and test 3, test for errors using Verilog compiler. Once you do this, in the right side you can see the worklib folder. Under worklib, so two modules will appear, and3 and underscore test. So both, first you have to select and3, you have to elaborate the design to recognize adware modules, then again and test 3. Fine, once you elaborate it, then so under snapshots, fine, again for testing for testing your code, select and test module. So don't select and 3 module. It's fine, this is a Verilog code, so we are about to test the simulation. You have to test only and test module. Fine, the verification, sorry, test bench module only. Fine, you select that, then you have to go for simulation. You have to launch the simulator. So if you click on the simulator, right, the simulation environment will appear. Just close this. It's a welcome window. Just close this. Now the corresponding test bench module will appear here in the left side. If you click on that, all its input outputs, recognized input output lines will appear in the right side. Find the objects. So you have to select all the lines, so input output lines. Use control and select. Fine. Now right click on this. Here you can find the option send to waveform window. Fine. I click on that. So simulation window will appear. Here you have to set the simulation time. To set the simulation time, you'll go here. So if you run directly, it will run by taking its corresponding timeline, it will run. Or if you want your own time, simulation time, you can select here. So based on the delay you have given, you can select the corresponding time. If you run, okay, okay, zoom in. Okay. Now we can see for all the operations. See, 1, 1, 1, 1, 0. Right. So this is all about the simulation. Right. Any doubts clear? Same thing. So this is for the beginning. When the very first, if you are creating the folder, so this is the steps you're supposed to follow. Fine. Let me close this. So once you have created all these things, the next step is very simple. So once you come out of this, so once you come, okay, let me exit this. I'll show you that also. Otherwise, you will again and again, you will going to create the same folders. Fine. So what you have to do in the once you created this, fine, when the so what you have to do is go to Verilog, then invoke, then source csrc. You'll see this, then set the design directory. Fine. Here only you can select your folder, right? So we can see that. Let me show you that 4VBAC 16. Sorry, 4VB16 EC x66. Fine. Now you have set your directory. Here you will going to change the directory to RTL. Now you are in RTL. Here you will going to write using gedit. You're going to write the files and all those things. These are only three steps you have to do. So once you've created all the folders, fine. Okay. Any doubts still here? If you have no doubts, and any doubts? Okay, I'll share this video. So if you have any doubts, you can watch it again. Okay. Okay. Thank you. So in the next lab we will do the synthesis. So for that we have to write a TCL language, TCL code.